Well, hello everybody. I'm going to do a review on this portable transistor mini spot welder I picked up off Amazon. I've got a lithium hand vac that I need to rebuild the pack in because it just doesn't run for more than a minute. It's many years old. And in lieu of buying a new vac, occasionally I might want to rebuild a pack out of a battery. I've never done this before. I'm just dipping my foot in the door. They have other ones of these for more money that have batteries inside them already. In this instance, you have to supply your own power source. But this is the exact pack, or kit rather, I purchased for $29.69. The reviews are spotty on these at best. I'm going to get into mods that people are doing, things like that. And we're going to eventually make it all the way through to testing on some nickel strips and going for the pack rebuild. What it comes with is simply everything you see here minus these battery clamps. The ends are not terminated. You will have to figure out a way to terminate your own ends depending on the power source you're using. On my case, I'm using a car battery, therefore I've got some quick release clamps installed. The document that came with it is, I guess, adequate in a way. It tells you how it works, but it really doesn't tell you how to hold things and make the packs. But the leads do not come attached. You'll have to attach them, and we'll get into this here momentarily. But I need to tout some battery selection specifications, I guess, because this is really the most critical part to keep this thing working without blowing out the MOSFETs, and we'll get to that as well. A 12-volt automotive battery, 25 to 40 amp hours. I'm not sure how you would get that rating. Those aren't on automotive batteries. Requires good performance and a small internal resistance. So you need lots of current flowing in a short amount of time. The second option is a 4,000 to 6,000 milliamp hour 45C 600S aircraft lithium battery, and the third is a 35 amp hour 12 volt capacity lithium battery pack. Now I'm taking this to assume minimums for specs. Everything down here pretty much is just functions. I'm going to cover these in a moment, but once you power it up, there's a power button right here. You will press it to turn it on. It may beep a couple times or something, and the LCD screen should illuminate. It's going to show weld energy from 1 to 99. You can set it. I'm assuming those would be in millisecond pulses. 5 would be 5 milliseconds, 10 milliseconds, and so on, all the way up to 99. That seems pretty hot to me for 99. But the second thing it will show is the display supply voltage from the battery source itself. We'll test that battery to here and see how accurate it is. And then this third button over here is they call it the weld way. It's basically the way you're going to weld, either automatic or with an external trigger source. When it's set on auto, when you take your probes and you put them down on your nickel strip, it will pause for 1 second, and then it will automatically create the spot weld for you. Then you can move to another source and it will do that as well. And I believe after it completes, or while it's completing the spot weld, it will beep 3 times. This is for a remote trigger. You can put this here and either wire in your own momentary switch, not on off, just momentary on, and then it will turn back off. I don't know why you would do that. A handheld button, because you're already using 2 hands for the leads. Or more appropriately, you could wire this up to a foot switch. If the auto function works well enough, I see no need for this at all. Those are the basic functions of how it's supposed to work. Now I'm going to take the top off, and we're going to get in for more finer detail and let you know what I know to this date as a novice. All right, well, I've removed the screws, and I just noticed right here it says DC 9 to 12 volts. Pay attention to power polarity. Now, that indicates that you could use a 9 to 12 volts battery, I guess, but I believe that's a range. Perhaps it shouldn't drop below 9 volts, or that's where some of the problems people are having with these could probably come into play, and that would be blowing out the MOSFETs. These are the 5 MOSFETs right here. And if the battery voltage gets so low, these things don't remain fully saturated, and they can either blow open or blow shorted closed. One of those two. I'm going to link a video to a guy who did a great job with oscilloscopes and whatnot and did a modification to his. I'm going to get into that modification momentarily because this daughter board that's in his is not what I have. It's not the same. So we'll come back to that. So you can see in here, this is another difference right here. These brass bus bars, they're not on most of the ones I've seen where people are doing mods, videos, and this, that. But as you can see, mine clearly came with them. They had a solder trace across here, and they maybe added extra solder across these buses. And other people were adding more solder on top of that to beef them up some. But these are nice, looks like 1/8 inch potentially bus bars soldered on there. So I think those would have no trouble flowing the amount of current that needs to run through all of the circuitry. Another thing people are doing is not putting their output positive lead on this end, because all this trace does is go from this input side to the output side. So they're just doubling them up right here and foregoing that entire trace. That sounds like a reasonable solution to me. However, I'm going to check the resistance on this and see if we get any drop between here and here as we move along. But I plan on using mine as intended, because it just seems like it would be easier to use with both these leads coming off of one end. Now, that's all there is on this board right here. Outside of this, I believe that's a 20,000 microfarad 25 volt capacitor. Now on the back side, I'm not going to take it apart, but there are only 5 diodes across here that are probably doing something with the MOSFETs. That's all this is. Now this board right here is what's different. The mods I'm seeing is they are taking I believe a 16 or a 25 volt 1000 microfarad cap, and they're putting the negative side on this terminal right here, this through hole, and the positive side they're going to this diode and attaching it right there. I'm going to try to pull up a side-by-side on the gentleman's video, which I'll link to in the description as a source for people to watch, and I'm going to try to pick out the differences in here, because this board is different, and it may have already addressed the problem with low voltage blowing out the MOSFETs. I'm not sure, but I personally am not going to do the mod. If that be the case, I don't know if it would create another issue. And secondly, I know I'm going to be using a battery that is more than enough of what this requires. All right, well, I've paused that gentleman's video on what I wanted to illustrate here. Pretty much everything closely from this part of the board up diagonally to these resistors right here. Everything to the left of that appears to be identical by my eye. So I'm just focusing in on the differences that I see. Number one, he's got a surface mount capacitor right here in this corner. This one's a through hole electrolytic. No big deal. Moving to the right of that, the left of that, there are 2, looks like resistors right here with a little transistor, and then a series of resistors pop up to right here. Back down one resistor just to the right on his, looks like a capacitor right here on mine that is not on his. And then it goes to, I believe that's a transistor as well, that shows. But let's move directly up off of both these transistors and look at this. Here's another difference. There are two resistors, looks like, on my board, none on his. Moving to the left a little bit, it looks like he's got a resistor right here, but this has a transistor. And then we move up into this component, and they appear to be the same, even though the positioning may be a little bit different. But look at to the left of his. That looks like a resistor, potentially a cap. But to the left of this one, that looks like a diode to me. And then even further left, that looks like a choke or some kind of a coil. Then we move back over a little bit and up. I'm not sure what he's got on his side, but this looks similar. A cap and probably a resistor right there. Going left of that, looks like two resistors here, nothing on his board. And then we have an IC here on his and an IC here on mine. Note, he's got 8 legs on that IC. This one only has 6. And then moving out to the left of that, he's got a series of 5 capacitors or resistors right here. This has a little bank of 4. Looks like 1 cap, potentially 2 resistors. But here's the diode that people are going from this ground, negative lead, to the capacitor, to this diode. Well, the diode position is not even the same. His looks like it's directly under the switch off this one leg, but this one comes right out to the left side of it. So these boards are different. So before doing mods or whatnot, I'm not going to do it because I feel like this is a newer revision that possibly fixed the problem of low voltage blowing out the MOSFETs, potentially. But like I said, because the differences are so extreme between the circuitry on his PCB and this one, I'm going to leave it well enough alone. That's just fuel for thought. Do your own research, but let's continue on. Well, I did briefly want to touch base on these clamps for anyone who's interested. They too were ordered from Amazon for $5.99. For that, I got the 2 clamps and then 2 of the felt rings, a red one and a black one, I believe. They are marked on the bottom. This is negative and the other one is marked positive. They came with all the anodizing in places scratched off. For me, I don't care, but that may matter to some folks. When they arrived, this cam lever was in there 180 degrees, and this steel cup right here was down on this side of the clamp. Well, there's a shoulder that is cast into this. Usually there would be a square-headed bolt in here, and that shoulder prevents it from turning, so you can just use one wrench and tighten up the nut on the other side. I simply just turned it around the other way. There's a washer in this thumb screw. You dial it to a reasonable tension and then clamp it in the rest of the way. Not sure if it matters, but this particular piece underneath in that cup is plastic. That would have been better to have that be a piece of steel. I don't know if heat or time may cause that to fracture and bust apart, but like I said, for me, they're going to fit the bill because they're really not going to be used that often. All right, well, speaking of the leads and the probes, the jacketing on this it feels siliconized. It's really flexible and pliable. These are 10 gauge. They have a 200C rating on them. I'm not sure the equivalent into Fahrenheit. You can look that up on your own. Underneath this heat shrink right here appears to be 2 heavy wall copper tubes. I do not know if they're solid and then they just created a hole in the end, but they have been crimped very well with a hex die on both ends. But the probes themselves are kind of odd. They are a solid piece of copper that runs down into here, but for some odd reason, they have been machined offset, like an eccentric. I don't really know why that would matter or why they would do that, but it is what it is. I do not know. I did a brief search to see if you could find just replacement probes. I didn't really find anything in a short search. So if these wear out, I don't know, you get a new unit or try to find a source or make something up. But let's try to check some resistance here, starting by the internal resistance of my meter. Looks like we're getting pretty much 0.2 of an ohm. So let's start out here touching on my connector to here. 0.2 of an ohm. So pretty much zero resistance between there and there. And the strands that are in this, they appear to be aluminum, but I'm not too certain about that. But there are tons of them in there. They're so fine. There must be hundreds and hundreds of strands in that. Let's go to the other side and check it. See what we get. Same, nothing. Let's move out to the probes. Work our way back to the middle. Try to get one probe. A little bit more resistance on that. Looks like 1.2 ohms, call it an ohm. Let me get down here and see if that changes any. Well, I'm reading 0.4, so maybe 0.2 of an ohm. I was on top of that screw. Let me try to get the connector itself. Yeah. 0.2 of an ohm. Let's try this one on the connector itself. Two-tenths, so basically nothing. Let's go across these bars. I'm going to try on top of the screws first. Virtually no resistance. Let's go from this blue out to the end of this bus bar. Same. Virtually nothing. Let's go from here to the end of this bus bar. Virtually nothing. So just for grins, let's check the whole lead from here out to the end of this probe, since it's a straight through shot. See what we get. It's bouncing between 3 and 2. So pretty much no resistance. That kind of fills out my attitude that because they put these copper bus bars in here, it should be no problem connecting them as designed. To put it back together with this daughter board, you've got to just tilt it sideways and make sure you get all the pins in the headers. Push it down, there you go. This did come with a protective screen cover on it with a little pull tab, but the pull tab was underneath this, so if it bugs you and you don't want it there, you're going to have to remove this with 4 small screws, pull it off, and put it back together. No big deal. Alright, well, just for reference, I'm using this 875 cranking amp battery out of my car. It has been charged, it's fully charged. We are going to verify things, but let's get this hooked up. There's one connector. Now this may or may not spark, so if you're alarmed like things like that, then beware. It did not. A little tighter. Alright, well, let's turn it on and see what it does. Contact. So 3 beeps, it lit up. Trying to show you the screen. The top line says Weld Energy, and then it looks like the setting is on 10E. It shows the input voltage of the battery is 12.6, and it's currently set to auto. So let's see, flip it to manual. Went to manual, back to auto. Let's try down. 9, 8, Yep, starts at 1. I think we may start on 5 for our first test and inch our way up to it. And that is something else I believe is correct, is depending on the battery and how much current it can flow, things of that nature, you'll have to play with this to get the sweet spot for the strips and then the strips to the batteries to make sure you get a good weld without blowing through. Let's turn it off and see what happens. It just turned off. Now it does have that large capacitor in there. I'm going to disconnect a lead and let's see if that blades off itself or if it, what it does. And it did turn on. It shouldn't stay on very long. Let's see how long it takes. Not too long. That was that capacitor bleeding off. It may have a bleed resistor there in somewhere. There's nothing on the bottom board close to that capacitor, but that may retain a charge. Let me turn it off. I'm going to hook it back up, see if it sparks. It did not. And okay. I did purchase this pure nickel strip off of Amazon, and there are many selections here, 3 of them. The one I needed was 0.15 millimeters in thickness by 10 millimeters wide, and it came in a roll of 5 meters in length. Now there are issues with ordering this off of Amazon. Even this one, if you read the comments, there'll be a lot of people saying it's not pure nickel. And when I say pure nickel, I mean 99.96%. From my knowledge, pure nickel is what you want over nickel-plated steel. But a lot of the Amazon listings will say pure nickel in the title, but if you drive down into the listing, it may say somewhere else that it's nickel-plated steel. Now, this particular one we're looking at, one test you can perform on it is a saltwater test. Leave it in salt water for 6 to 24 hours, and pure nickel will not rust, but nickel-plated steel will. That's one test you can do to verify. I'm not going to be doing that particular test. Another one is a spark test, which I will be doing. If you put it on a grinding wheel or some kind of a Dremel tool with a grinding stone on it, pure nickel will not spark, but nickel-plated steel will. You can see this example right here. That is nickel-plated steel. This is what we're going to be looking for. No sparks. With that being said, if you read listings, like I said on this one, they're going to be in and out of the mix. But I can tell you what I got was pure nickel. And that's the roll right there. I've cut off a sliver, and we're now going to go to my grinder. I'm going to start it up holding this with a pair of pliers, and we are going to verify that there are no sparks, and I can tell you there will not be any. Well, okay, did anybody see any sparks on that test with my grinder? I sure didn't. Another thing that people claim is that nickel should not be magnetic. It should not be attracted to magnets. Well, that in itself is not true. This is obviously pure nickel or close enough to it because there were no sparks, right? But watch this. Sticks right to it. That is not a valid test, in my opinion, to say whether or not this is pure nickel. It is, and as you can clearly see, it is attracted to that magnet. The other test, like I'd mentioned, would be a saltwater test. I'm not going to do it for the video, but this is irrelevant to me, so maybe I will throw that in a little cup of salt water and leave it for a day and see what happens. But I can tell you, as far as I'm concerned, I'm satisfied. This is exactly what I was purchasing, and it's advertised exactly like what I received. We're getting ready to test this thing out for the first time together. Let me turn this on. Now the input voltage on this is claiming 12.6 volts, a perfectly charged battery. Let me go up to the terminals here and see where we're at on an actual meter. 12.79. So technically my battery has more voltage in it than what this unit is saying, and that is in my favor. All right, well, I've got a sacrificial board up here in case anything burns, and 2 little strips that I just cut off there. Let's go ahead and turn it on. It's getting ready to happen. Okay, it's on auto mode, which is what we want. I'm on 5, level 5. So that's where we're going to start. Now, here's what I know about this through my research. People have a tendency to gorilla on these things and put way too much pressure on them, and that changes the resistance or something along those lines, and they don't work properly. Ideally, you put just enough pressure on these probes to hold the material flat to itself at about, let's say, a 45-degree angle, something like this. That's what I'm going to try. Like I said, guys, I've never done this before, so here we go. First time on 5. I don't expect a perfect weld the first time. So here's one probe. And that was it on level 5. Now let's see what happened. If I try to peel these apart, I could get them apart. They did stick together, but not nearly enough penetration. Okay, so we're going to try it again. But I'm going to take the level up to 10. Then I have another idea. So that was 10, and I can tell you right now that probably was not enough either. No, definitely not. All right, I'm back now. What I want to do, let me hit min max. Which one am I on? That's the maximum. I want minimum. You can see my battery voltage right here at 12.76. I have ramped this up to 15 on the energy, but I want to record how low the voltage drops on this battery when we apply the probes and it does the weld. Okay? So let's try it. That went down to 11.84 volts. Now that was a pretty healthy spark there. I don't know if I didn't have good contact or what was going on, or maybe I'm pushing too hard. I'm learning. It's getting better. Every time I pull it, these are not going to be flat anymore. I may try to flatten that out with something, but let's try this other end. I want to try that on 15 again. Can I reset this? I don't know how to reset it. So let's just do this again. Like I said, I'm experimenting. I want the minimum voltage. So here we go again. Definitely making contact. Holding it down, but not gorilla gripping it. 11.76 to the drop. Yeah. Wow. Ah. One side did come loose, but it's tearing the metal. Yeah, dang. Man, 15 might be the ticket on this, but I'd like to... Oh, man, that's on there. 15. Can I... I've got one pair of pliers here. I'd like to get it apart and try that again. Ah, there we go. Yeah, that tore both of them at 15. That was actually pretty impressive. I'd like to overshoot it and then come back down. I'm going to try something here and see if I can kind of flatten this out. That's working well. That way I can use as much of this as I can without wasting it. Nice and flat. All right, let's set this up again. Still at 12.76 volts on the meter. Minimum rating. And we're still at 15. I want to take it up to 20. And just see what kind of a burn through or whatever we get. So far, I don't think I've done any damage. These little pop marks were already on this piece of wood. All right, that's nice and flat. Here we go. Well, that was a good, nice spark. This one side, I see it developing right there. And over here. It did not burn through. And this was the top side. You can see a little burn mark around that. And a tiny little burn mark around that. So somewhere between 15 and 20, I think, is the key number, at least putting these two strips together. I was able to get it off, but it did tear. Tore both of them. Let's do one more at 20. How about that? Or do we go to 25? Let's do another one at 20. I feel like we're right in the range already. Try to pick an area that has not been touched. I know this is long-winded, but I'm learning and trying to educate at the same time based off of what I've learned. Just enough pressure to hold it down. Ooh, getting hot. Okay, that one blew through. So 20 is too hot. I gave it less pressure that time and I got more weld into it. So let's go back to 15. You know, from what I'm gathering, there is a tactile feel to this stuff. And I have not developed it yet, obviously. So I'm going to try even less pressure at 15. Kind of running out of places, but we'll find a place. Okay. Light pressure. Just barely enough to hold it. Light pressure. Wow. They were right. That light pressure, the lighter you put the probes down, the more aggressive the weld. It punched right through that. Let me go back down to 10. Try to do it again over here. Just barely enough to hold it down. Not bad. Yeah. Let me play around with it a little bit, and I'll come back and describe what I find. All right, well, I've been playing around with this thing for a little while, and I got some decent ones, and I'd try it again, and then I'd blow through or not. So I cut a couple of new pieces here, and I'm going to try to keep everything symmetrical this time so I know which weld I was doing. So I've got these direct across from each other, and let's see, what was the top side? This was the top side. And then on the bottom side, it looks like I partially may have burned through. It's really hard to tell. So I'm going to peel this apart. And that was on 15, by the way. Let's see if I can peel this apart and see how well it's holding. It did hold well. It tore this one, and started to tear that one. So let's see if I can flatten this out again. And I've been playing with pressures on the probes. I am somewhere between barely holding down and moderate. It's hard to describe. So I backed this down to 13. Let me turn it this way, so we can try one at 13. Trying to mimic the way I did it last time. And instead of holding these like 45s, I went more like a 60-degree included angle. So let's see what happens here. Just moderate. I mean, I'm pushing it down to make contact and just the slightest bit more. Looks pretty good at the top. And that actually looks pretty good at the bottom. It's hard to tell if this one kind of burnt through. It certainly didn't burn a hole through the top. I just don't want to burn a hole in the battery. So 13, what I'm calling a moderate pressure. See if I can do this with my fingers. Yeah, that might be, yeah, well, I certainly can't get it with my fingers. I can tell this one is starting to rip. Yep. And that was definitely the one on this side, which would have been the positive probe. Had a little bit more on it. But I kind of feel I'm right in the ballpark. It's just more technique than anything right now. So let me try that again. Okay. So just holding. Come on now. Come on. Stuff's like glass. Just touching and a slight amount. Let me try to reverse this. Don't use both probes at the same time to align things. Touching, slight amount. Get back to my 60. Touching, slight amount. Touching, slight amount. Okay, so now the first probe I put down looks like a heavier spot than the left. And you've only got a second to try to equalize those. Big tear. Tear. I don't want to blow through the bottom side in any manner. Let me go up to 14. Same principle. You know, you've only got 1 second before it fires off, so to try to, you know, get everything equal, I guess I can try coming down at the same time, but it helps to have one kind of held. I'm going to try that, though. That actually looks really nice, coming down at the same time. Ah, man, look at that. Yeah. Not coming apart manually. I know this is long-winded, guys, but, you know, I'm trying to figure this out. All right. 2 nice through-hole tears on that piece. Should have marked what was the top. And it started to... Now that looks good. I'm kind of feeling like 14 might be the ticket, at least on the strips. I'm going to flip this around to the other side. I do not want to lay 2 probes at the same time. I like the ability to hold things in place. About that angle right there. Come in here. Wow. I'm trying to find you guys. That's the bottom side. Part of the black you're seeing there is it burning my wood. Did not penetrate all the way through. I've got 2 nice spots right on the top. See those? That was 13 with just heavier than barely touching. I'm going to run a couple or 2, 3 down here and see if I can replicate that. Sound good? And I do want to try to come in at about angles like this. Okay. Let that lead down. Should probably pick up 1 lead first, because as I was breaking those 2 out at the same time, it wanted to fire again. Break 1 lead off at a time. Break 1 off, break the other. One off, then the other. One off, then the other. I'm speaking my mind. See, I didn't do it. Try to take them off at the same time. Woo! It's getting hot. Woo! Don't touch that. Woo! Can I hold it on the edge? That's looking pretty good to me. Top side. These are where I was tearing stuff out, but what do you guys think? Hide the ones where I was tearing them out before. Doesn't look too bad, eh? So I'm calling it at 14 with just beyond the barely hold it light pressure. And just for grins, I'm going to do one this way in the middle, barely holding light pressure. Now we already know these are tacked together, so they are in contact pretty well. Barely touch. See how much weld that was? See the blowout arc on the top? I was just barely touching. Blew a hole clean through it. That's what I was trying to say. You know, depending on your technique, the power of the battery, and where you have it set to. Now I'm going to try one over here next to it with just my little moderate pressure. See how it didn't really blow sparks? There and there looks great. There and there looks great. It is tactile and experience gained over time. I feel really good about that personally. Like I said, I know it's long-winded, but I'm letting you show the trials and tribulations of what I'm going through to make this thing work, because technique is 90% of it, in my opinion. Trying to keep my head out of the way. Make sure I'm on auto. I am. Okay. Here we go. Whoops. That feels good. Okay. I'm going to go ahead and try a negative over here. I'm going to go back and forth to not introduce too much heat into the cells. I'm putting 4 on each. I'm not going to do a peel off test, but it's on there. Okay. Let's do a couple more. Looks like we bridge from here to here. That gets nothing but a wire, bridge, nothing but a wire. Okay, so negative, positive, negative, positive, negative, positive, negative. That's correct. Let's go again. Again, starting with this side. Turn that over. Put it about like that. Try to pin it down with one lead. And here we go. Not much warmth in there. Let's see, that was 1, 2, 3, 4, 5, 6, 7, 8 spots. I'm going to turn this off, and I'm going to slide my pinky in here and see if I can feel the MOSFETs. They're not even warm. Okay. Well, that's going well, I believe. I'm going to show you one more, and then I'm going to pause, and I'll bring you back. So not waste too much time. The video is already getting extremely long. I didn't turn it back on. I'm going to put 2 more on this one. That first one didn't feel quite right. I can't describe it better. Okay. One more down here. Looking good. Well, all right, we're coming down the home stretch. I've made some tabs here, just cut things in half, made tees, this, that, and the other. In my opinion, all the spot welds look really good. I'm going to show you an issue on the other side. I did the same thing over here, created tees and made this tab. You can see right here where there's quite a bit of burning on that one. That was my mistake because, like I'd said before, this is a tactile thing. I was too light on my probes. It works, but something to be aware of. Well, all right, guys, my final thoughts on this is it did exactly what it was supposed to do. I fed it with enough power. I used it right out of the box. I did 0 modifications to it, and I successfully rebuilt a pack. This is, like I'd said before, a tactile feel. You can't just gorilla these things down. You don't put enough pressure, you blow through. You put too much pressure, you don't get a good spot weld. You have to play with it and get familiar with it and develop the skills to make it work properly. But aside from that, once those skills are honed and developed, it worked just like it was supposed to work. I'm completely satisfied with 0 mods. I believe, like I'd said, this is a revised version, but it did the job for me for $29 plus a little bit of extraneous costs for other items I needed to complete what I will call the kit. I hope this helps someone in some way. Thanks for watching, guys, and good luck.